get derivatives xt params. I've forgotten my comma there. That's here. Put that back in. Save, run. NP is not defined. I've not imported it, so import numpy as np. Save it, run it. X and Y must have the same dimension. So this is, if I scan up, I can see which is causing my problem here. And it's this plot, so recorded T, recorded X. So let's see what's happening. I go back to here, just look how I set up my X next. It looks right to me. So I'm just pouring in, so remember return X next, I'm just putting that X, so X is the same thing, so I can't see why I'm getting my error. So what I can just check is that this is doing something sensible. So down here I can check what's in recorded X. Let's see. If I say recorded X, print recorded X. Now I know this is going to be a huge vector, so recorded X 0, 1, 2. So I can see, as I expect, it starts in A, decreases, so these are all rounded, so slowly flowing through the system. I think I have about, well, a lot of time steps, so let's do 100 out of range. Okay, so this indicates I might have a problem, because what was my time step? Step size of 0.1, so I'm supposed to have at least 15,000 steps. So the fact that recorded X doesn't go up to 15,000 is a problem. So I'll just say len recorded X. So 5. So for some reason I'm only running this over 5 time periods. So maybe let me just check how we call this linspace. Numpy linspace start, stop, and number. Okay, so that's what I'm saying. So I'm supposed to be saying 0, 1500, then 15,000 points. Okay. Let's see. Time start, time end, number of steps. So I might say, what's in this T array? Let's have a look. Len T array. Oops, I wanted to do this in my window. So len T array 1500. So that got created, but somehow this ODEInt function is failing. It's only going so for I equals length T, Ti equals this, so you see for some reason I've left 2 loops in here, so I made a mistake. Oh no, that's right. So X, so I've got for I here and I've got for I here, so I'm calling it. So even though this loop is nested, so firstly I say for each time step use I, and then here I'm saying for each element of my X vector, so A, B, C, D, use I. So that is not good code, because there's a value of I here and this loop is overwriting this one. So I suspect that if I call this J, hopefully whatever was happening is going to sort itself out. No, so it's still having that same problem. Length recorded X is still 5. So it was actually not giving, this suggests it wasn't giving an error here. So now I'm saying it's only giving me 5, so let's go print ti. So I'm expecting that to increment. Here's all my errors from plotting. Run this. Let's cancel this plot because my code's not running yet. Just trying to debug it. Save it and run it. So time is 0 and then it's stopping. Print ti, so for I in range length t, so let's go print ti I, so we know that should start at 0. Might just go print len t. So that's the length, and for I in this range, so that's right. So ti is that, print tii, so x next equals x current. So I'm not sure why I'm calling that up here, because I define that here. X next equals y current. Let's try that again. So delete that. X next is not defined. Right. So I need, that's why I had that in there, just to give me a vector of the same shape that I can write into. Let's have a look. So why is it stopping? I see. You see, for I is in range here, do this loop, for j in range here, and then after it's exited this loop it does this line, which is still in this loop, and so it's saying it's only running this once because my return results is in that loop. So at the end of the loop, or rather at the end of the first time it runs around the loop, it returns, rather than running through and then returning once it's built them all up. So I'm pretty confident that's my error, so I'm going to delete these print statements. I'm going to run it. Okay, now I can just have a check. Length recorded X is now 60,000, and if you like, that's because results.append X next. So in actual fact, I only want to append this after I've worked them out for each element. So if you like here, I'm going to say loop over elements in X. Here is my loop over all time steps. So I only want to append X next once I've looped over all the elements in it. So now let's run it. We can restore all these graphs. See if that works. X and Y is the same dimension, so that's a problem again. Recorded X 1501. So for some reason I've got one extra step. So the I in range length t, but I've already increment, so the number of steps is actually -1. Because I fill in the first time step here, I think I need to decrease that by 1. So then this will run for 1500 steps or 15,000 steps. So I can either decrease that by 1, or for instance up here I can say results append x next. X current. So at the top of the loop, I put it into. So now I'm just changing this around. So I read the current values and store it in results, and then I calculate the next value. Okay, and then I replace that into. Again, that can be outside my loop. I only need to overwrite this value when I've finished it. Right. So you can see, just you've got to stay awake and think about what your loops are over. Think about what you're overwriting. It can get quite complicated. So here now, if you like, I go one time step past the end that I don't end up storing, but that's okay. Okay, so the first time step is here. Run. X and Y I've still got this result. So length recorded X 15,000, length recorded T is 1. So I didn't record. So instead of recorded T, this is just my T array. Okay. So instead of recording the T, I've passed the T array I want here. I've calculated it here. So when I plot it, I'm going to be plotting it against a T array. So plot time against recorded X, or plot recorded X against time. Run, recorded T not defined, line 86, and recorded X, don't need my X here. In fact, I'm overwriting it here, so I don't need that there. Right, run. So debugged my code, and I've got the result I expect. But now all my initial conditions are in one place up here. So I can change the volume of water originally in A, rerun it. See it start. Change my graph as well to reflect that the maximum volume is going to be 2. Rerun. So it starts at 2 and falls now. Or I could change the plug hole. So let's say the plug hole in bath C is very big, so water flows out faster. Run that. So you see that now the water level in C stays much lower because I've got a bigger plug hole there. So that's as expected, or this result is consistent with what I expect. Let's change it back. Right, so I've now got myself into a form where my ODE integrator here is the same form as the one that is included. So I say p.ode int